Okay, balancing redox equations by the half reaction method. The first step is to write balanced half reactions, and this is probably the most challenging part of it, but you need to do about 5 steps in order to write each half reaction. So we'll begin by writing the skeleton equation and then balancing all the atoms other than oxygen and hydrogen. We'll add water to balance oxygen, hydrogen ions to balance hydrogen, and finally electrons to balance charge. I'll just highlight for you here that this step and this step are the ones that people make errors with typically. Step B, people just forget to do it, and step E has to be done last. Sometimes people add the electrons before they've taken care of the other atoms, and you have to do it last or it will not be correct. So I'll just highlight that for you and we'll go through examples together. Once you've written the 2 balanced half reactions, then you need to make the total electrons lost equal the total gained. So this is consistent with what we've done in the past. So you'll use multipliers to make that happen, and then you'll be able to algebraically add those 2 half reactions, canceling the electrons and simplifying where possible. Now, the simplification, sometimes people need to write that out in a couple of steps. I'll show that in one example, writing it out, and then I'll show another example where I do it all in the same step, which is faster on your page, but you need to do it in a way that you understand it. If basic solution is the instruction, then you'll need to handle that as before, where you add hydroxide ion to both sides, form water from the neutralization of the hydrogen ion, and simplify. Always check that the equation is balanced for both mass and charge. So here you're counting the number of atoms of each element, and here you're checking the left side, right side charge, just like we did before. You'll notice that I have written out the same 4 examples that we balanced by the oxidation number method, so I want to show you that both methods can be used for a number of different equations. You may in fact have a preference for either method, but you are responsible to know both, so I suggest you practice both. Okay, so here we go in example 1. First step is to write the balanced half reaction. So we begin by writing the skeleton equation. So we pull the iodine containing reactant and the iodine containing product out of the original question. And now we do step B, which is the one that people often forget. We balance the atoms other than oxygen and hydrogen. Well, there's only iodine here. We see there's 1 on the left and 2 on the right, and so I'll put up a 2 here so that I have 2 iodine on either side. Now we add water to balance oxygen. Well, there is no oxygen, so I don't need to do that. Hydrogen ion to balance hydrogen. Similarly, I don't need to do that. And so now we're on to the electrons. So when you're determining where to add the electrons, count the total charge on each side. So I look at, maybe I'll do this in green. Look at the left side here. I see that there are 2 particles of the iodine ion, which were both -1. So that's a -2 charge in total. Actually, if I write it up there, you might think it's an oxidation number. I don't want to do that. So we have a -2 charge on the left side, and the element of iodine here is neutral. So we add electrons which are negatively charged to the side of the equation that is more positive. If I were to add the electrons to the left side, that would just make the -2 become more negative. It's not going to make it equal 0. So I need to add electrons to the right side so that I've added a -2 charge, and 0 plus -2 will equal -2. So you can see here now that the charge is balanced. So I'll just review that. I counted the total charge on the left side and on the right side, and whichever side was more positive, that's where I added the electrons. Because they're negatively charged, they'll essentially lower that value, and that's what I'm trying to do. I'm trying to lower the positive value until it equals the -1. So lower this 0 until it equals -2. All right, so there's our first balanced half reaction. you can see that it's the oxidation half reaction because electrons are being lost. Now you can anticipate that the second half reaction will be reduction, and if it's not, you have a problem. Okay, so something's wrong, you need to go back and find that. So let's look now at the chlorine half reaction. So we pull the chlorine containing reactant out and the product, and now we balance atoms other than oxygen and hydrogen. And so we begin here with 2 chlorine on the left, so I need 2 on the right. There's no oxygen, so no water to add, no hydrogen, so no hydrogen ion to add, and now we add electrons. So check the charge. Here we're neutral overall, and here we're at -2. So add electrons to bring the positive charge, or the positive side, down to equal the negative. And so now we have 0 plus -2, which you can see equals -2. And so that's now the same as the right side, so it's balanced for charge. Okay, after this, now we have 2 balanced half reactions. So now we go ahead and algebraically add these 2 equations, checking first that the total electrons lost equals the total gained. And in this case it does. We have 2 electrons being lost and 2 electrons being gained. So I don't need to multiply those equations by anything. The total electrons lost already equals the total gained. And now I can go ahead and add them up. So on the left side, I have 2 iodine ion plus the Cl2, and that forms an I2 plus 2 of the chloride ion. And so this is the final answer. And we can check that it's balanced for mass and charge. So there's 2 I's, 2 I's, 2 Cl's, 2 Cl's. Charge over here, -2 plus 0 is -2. Charge over here, 0 plus -2 is -2, and so it's balanced for charge. Okay, example 2, the half reactions will involve oxygen, so a little bit more complicated. So you can pause the video and get started and see if you can, how far you can get, and then check back, or listen to another example as we go. So, skeleton equation for the chlorine. ClO4 negative is the chlorine containing reactant, and Cl negative, the chlorine containing product. Okay, I look to balance the chlorine first, and I'm going to keep saying that even though I don't have to do the step, because I don't want you to forget to do it when the time comes, when it actually needs to be done. So there's 1 chlorine on each side, so chlorine's good. Now we're going to go ahead and add water, and I'll add 4 to the right side because I have 4 oxygens here, so I need 4 oxygens on the right side. Now I have 8 hydrogen, so I'm going to go ahead and add 8 hydrogen ions to the left side. And so we have 8 hydrogen ions and 8 hydrogen over here. 1 chlorine, 4 oxygen, 4 oxygen. Okay, so we've done steps 1, A, B, C, and D. Now we balance for charge. So +8 here and -1 here. So +8 plus -1 is +7. And on this side we have -1 plus 4 times 0, the water's neutral, so really we just have -1. So how many electrons do we have to add to the more positive side in order to bring that charge down to equal the other side? Well, if you're thinking that you have to add 8 electrons, or -8 here, in order to bring 7 down to -1, you're right. Just think of a number line. So if you're at +7 up here and you have to come down to -1, there's 0. Here's 7 units plus 1 more. There's 8 steps we have to go. So we're going to add 8 electrons on the left side. Okay, so I'm going to erase this part of charge because that's how we do it, but what's important is the number of electrons. So there's the reduction half reaction. Okay, now for the oxidation half reaction. We have the bromide ion and the bromate ion. Check that the bromine are balanced, and we notice that they are. There's 1 bromine here and 1 here. And now we look at the oxygen. So there's 3 oxygen there And so we put 3 water on the left side, balance the oxygen. Now we add hydrogen, 6 on the left, so we need 6 hydrogen ions on the right. Now we check for charge. Water's neutral, the Br negative has a -1 charge, and there's only one of them. And on this side, the bromate is -1, and those hydrogen ions are +6, -1 plus 6, +5. So how can we get +5 to equal -1? We're going to have to add 6 electrons, right? -6. So we'll add 6 electrons on this side and bring that charge down to -1. Okay, so now we look at the total electrons lost and gained and look to make them equal. So we notice that we have 8 electrons being gained and 6 electrons being lost. So most certainly those are not equal, 8 and 6. So we look for the lowest common multiple, think of 24 there. And so we're multiplying that equation by 3 and this one by 4. So I'm going to go ahead and try to neatly keep track of this and make those changes to the coefficients. So 3 times 8 is 24. 3 times 8, 24. There was just a 1 there, so now there's a 3, same thing here. And 3 times 4 is 12. On the second equation, 4 times 3 is 12. 4 times 1 is 4. 4 times 1 is 4. 4 times 6 is 24. 4 times 6 is 24. Now I realize that this is getting a little bit tricky to read, so just, be neat and try to keep track. Maybe changing colors can help. So right now I'm going to cancel everything that's identical on the left side and the right side. 24 electrons, 24 electrons. Remember, that's the whole reason that we did these multipliers, was to make those two equal. Now, coincidentally, we have 24 hydrogen ions and 24 hydrogen ions. You won't always have the same number of hydrogen ions. Sometimes they're going to be left over, and you'll see in the next example that they are. But again, the whole reason we multiplied by 3 and multiplied by 4 was so that the electrons would be the same. That's a must. You have to do that. Okay, and coincidentally, the 12 water here ended up also being on this side. And so we can see as we add now the left side, we have 3 of the perchlorate ion plus 4 of that bromide ion that are forming the 3 chloride ion and the 4 bromate. And you can check that this is balanced for mass and charge. So 3 chlorine, 4 bromine, 4 bromine, 12 oxygen, 12 oxygen, and an overall charge on the left side of -3 plus -4, that's -7 over here, -3 plus -4, -7 over here. Okay, so far examples 1 and 2 were balanced in neutral solution. We didn't end up having extra hydrogen or hydroxide. So in example 3, that's not going to be the case, so I'll give you the instruction to balance example 3 in acidic solution. Okay, so why don't you go ahead and write the balanced half reactions and then check back with the video. Okay, so having a look here, we see I started off with 1 chlorine and 1 chlorine, so no coefficients to add there. 3 oxygen on this side, so 3 water to balance the oxygen. Now there's 6 H's, so 6 hydrogen ion here. Check the overall charge on the left side, +6 plus -1 is +5, and over here -1. So I added 6 electrons, +5 plus -6 will equal the -1. Now for the manganese containing reaction. There's 1 Mn and 1 Mn. Okay, now I look to the oxygen. 2 here and 4 here, so I need 2 more on this side, 2 water. 4 hydrogens over here, 4 hydrogens here, and now I check the charge, totally neutral on the left side. -1 plus +4 is +3, so I'd better add 3 electrons to bring that +3 down to 0. Okay, now check to see the electrons being gained in the reduction here and lost in the oxidation half reaction, and we notice that they're not the same. So we have to use multipliers, and in this case, multiplied by 2, and so 2 times 2 is 4, 2 times 1 is 2, 2 times 1 is 2, 2 times 4 is 8, 2 times 3 is 6. And now we see that the total electrons gained and lost are the same, and so I can start to cancel those. So I cancel the 6 electrons. Now, you could go right ahead and simplify the hydrogen and the water at this point. I will do that in the next example, but in this question I'm going to do it step by step. So I'm going to copy out everything I see on the left side after canceling the electrons. Okay, so in copying everything out, I need to simplify, so collect like terms, just like we do in algebra. 6 hydrogen ions here and 8 hydrogen ions on this side. So really, there's a net of 2 hydrogen ions on the right side. So whichever side is greater, which is the right side in this case, you swing the other one over, swing these 6 over. 8 minus those 6 would leave us with 2. Now do the same thing for the water. There's 4 water on the left, 3 water on the right, and so we'll bring the 3 water over and subtract those. 4 minus 3 is 1. And so we finish with no hydrogen ions on the left side. That chloride ion plus the 1 water plus the 2 MnO2, and that gives us the chloride ion plus the 2 permanganate ion plus the 2 hydrogen ions. And so I'm suggesting that this is the final answer. So you should check here to see if the equation is balanced for mass and charge. So 1 chlorine, 1 chlorine. 2 times Mn here, so 2 Mn, 2 Mn. 3 oxygen plus 1 is 4, plus these 4 is 8. 2 times 4 is 8. 2 hydrogen here and 2 hydrogen here. Now we check charge. There's one of these chloride ions at a -1. These are both neutral, so the overall charge -1. On this side, -1 plus -2 plus +2 is going to equal -1, and so we're -1 on both sides. Perfect. Okay, example 4, I'll show that the simplification happening all in the same step this time, but feel free to keep writing it out if that makes it easier for you. And let's finish this equation in basic solution. So basically, carry it through as you did example 3, and we'll deal with the basic solution at the end. So try this and then check back with the video. Okay, so check your reduction and oxidation half reactions here. We had 1 Te and 1 Te, 3 oxygens there, so 3 water here, 6 H's now, so 6H positive on this side, and be careful to keep writing the positive symbol when you add the hydrogen ion. Keep your charge correct. So +6 minus 2 is +4. We'll need to add 4 electrons to equal the neutral right side. N2O4. Did you remember to balance the nitrogen first? Remember step B, 1B? That's the one people forget. You don't have to do it like all the time, but you do have to consider it every time. See here, Te, there was 1 on each side, so we didn't actually have to put a multiplier here. Well, in this case, you look at 2 nitrogen and only 1 here, you do have to put this 2 here. If you miss that, it's going to change everything. So 4 oxygens here, but now there's 6 on this side. So in fact, the water go to the left, which swings the hydrogen to the right, and now our electrons to the right. And so we were neutral on the left, and so -2 plus 4 is +2. We'll have to add 2 electrons to bring that down to 0. All right, so total electrons lost equal total gained. Go ahead and use a multiplier if you need to. Cancel the electrons and then check back with the video. Okay, so at this point I have canceled the electrons after multiplying the second equation by 2 to make the total electrons lost equal the total gained. Now, I could go ahead and just add like I did before and simplify, but I'm going to do it all in the same step now. So notice that there are 6 hydrogen ions right here and 8 here. So in fact, if I take the 6 away from the 8, I'm really left with 2 here. Now, what about the water? There's 4 water over here and 3 water here. So I'll take those 3 away from both sides and finish with 1 water. And so I've saved myself a little bit of time, and I write out the left side now. There's 1 water still here, and on the right side there's no water left, 4 nitrate ions and 2 of the hydrogen ions, as well as that tellurium. Okay, so now because it said basic solution, I need to take care of that. But before I do, I'm going to double check that this is balanced. 1 Te, 1 Te, 3 O's there, plus 1 is 4, plus 8 is 12, and I see 12 on this side. 2 H's here, 2 H's here. 4 nitrogen, 4 nitrogen. Checking charge, -2 on this side, -4 plus 2 will be -2 on this side. If the equation was not balanced at this point, then that would have meant I made an error here, and I would have gone back to try to fix that. So moving on to basic solution, I notice that there's 2 hydrogens there, so I'm going to need to add 2 hydroxide to both sides to neutralize the hydrogen ion. And so these 2 hydrogen and hydroxide ions actually form 2 water. So those are not there anymore. Now I have the 2 water. Noticing that I have 1 water on this side and 2 water here, I can simplify there to have just 1 water on the right side. And so the final answer is 2 of the hydroxide ions plus the TeO3 2 negative plus the 2N2O4, producing the Te plus the 4 nitrate ions and the 1 water. So this is our final answer. Let's double check it for mass and charge. 2 O's plus 3 is 5, plus 8 is 13, 4 times 3 is 12, plus 1 is 13. 2 H's, that's it there, 2 H's. 1 Te, 1 Te. 4 N's, 4 N's. Now for charge, -2 plus -2 is -4. And then on this side, neutral, -4, and neutral. So -4 on both sides for charge, we're good.